Hi, I'm Instana CTO Chris Bailey, and in this episode of Inside Instana, I am joined by Saurabh. Now, Saurabh works here at the IBM Research Lab in Yorktown. So, Saurabh, tell us a little bit about yourself and how IBM Research works with IBM Instana Observability.
Thank you, Chris, for inviting me to your webcast. I'm a staff research scientist at IBM Research and also the product focal for Instana, which basically means I manage the relationship between IBM Research and Instana. We have a dedicated team working towards helping Instana to infuse many AI capabilities that can significantly improve, time to mitigation, time to resolution of the problems, and help customers bring the value of AI into Instana. And we've been doing this very closely with the product teams.
And this is like a huge kind of like superpower for Instana because IBM Research is the world's largest like corporate research capability.
Right.
And like here you do a mix of kind of like fundamental research and applied research.
That's correct. We have, as our customers know, we've been building Watson X, which is core AI capability for IBM. But at the same time, we are working with multiple products to infuse Watson X, and not just Watson X, many other AI capabilities that can significantly help our customers. Yeah.
Yeah, I mean, as kind of like foundation models, large language models, generative AI, kind of like, it really became something that was like apparent to people probably around March, April last year because of OpenAI,
Yes.
ChatGPT. I mean, it's actually a fundamental technology that we've been working on here for quite a while before that.
Yes, that's correct. So, actually, kudos to OpenAI for making people believe in AI. I think before OpenAI had ChatGPT, it was really tough conversation with customers to say how this can help. But once that was released, suddenly everybody realized the value of foundation models. And if you look at IBM Research and what we have been doing since many decades now, from Project Debater to whatnot, right? We've been at NLP for quite a long time. We are actually the leaders in this space, and we've been moving very rapidly, trying to infuse these foundation models and generative AI capabilities into many different places. I mean, you would see us even in tennis, for example, where Watson X, for example, is helping, record these and transcript, and also in stock markets and whatnot, right? So we are everywhere, and it's been helping. But most importantly, for our own products, eat your own dog food, right? We actually use our own AI capabilities in our own products because that's the confidence we have in our technology.
Yeah, and I think it's also fair to say that whilst AI is top of mind for everybody,
Right.
there are many other technologies in the toolkit. Right? It's not like AI is the hammer now. What's the nail?
Yes.
And again, whilst what's next and generative AI is kind of like top of mind for everyone. Your team kind of works fundamentally across the board on
Yes.
how to solve some of the hardest problems that we're trying to solve in observability and automated IT operations.
That's correct.
So what have you been working on most recently? And I know there's some stuff which is tech preview, currently coming into the product.
Right.
What's the thing that's on the edge of arriving that you've been working on?
That's a really good question. Actually, one of the things that we've been working on is root cause identification for Instana. And what is a root cause identification, right? You have a problem, right? Suddenly all the alarms and events get triggered. You get a PagerDuty alert or a Slack alert or email alert, whatever you have you configured. And you need your operations team is looking at a problem, and they need to they need to find where the problem is starting from. What do they need to go fix? But for them to fix something, they need to know what is the problem, right? And here is a interesting issue with any of these IT problems. They propagate. And once they propagate, the blast radius keeps increasing and increasing over time, and depending on how quickly you respond, you could reduce your blast radius, but also it gives you a narrower view of how to like come to the root cause,
Yeah.
right? And interestingly, right, a typical customer would have hundreds. They don't realize it. Actually, they think they are just, for example, they might just say, I've launched 10 nodes and 10 Kubernetes pods and whatnot. But that itself could be thousands of entities on a graph if you were to create it, because there are so many configuration deployments. There are a lot of ancillary things that happens behind the scene. And when you have so many thousands of entities, and you need to find which of those entities has a problem, you can't go keep looking on every 1,000 entity. So we need to somehow automate this whole solution, right?
Yep.
And one of the things that we've been doing, right? I mean, we in this case actually we are not using generative AI. We are using something called probabilistic AI, and one of the things that we've been able to do for our customers is to help them get to the root cause within few seconds of you identifying the problem or the alert getting triggered, and I think that's a superpower.
Yeah, so this is essentially like automating what ops teams do today, right?
Right.
They have to analyze all of this data and they have to walk through it using their knowledge of what is normal, what is abnormal. And as the scale of deployments is getting bigger, that takes longer and longer and longer. And essentially we're using probabilistic analysis and AI to accelerate exactly what the ops team does today and give them the answer.
Exactly, right? I mean, it's always, I give an example of a developer, right? You have a Python code and you have a problem. How do you go about it? You don't go and fix this problem in one go. You basically iteratively come at the solution. You go and search internet, you fix the code, and it's a very iterative process, right? And you kind of self-calibrate yourself. Actually, all of that knowledge and process is distilled into this tech preview root cause identification feature that's coming to Instana.
Sounds super exciting. So can you show us this
Yes,
working?
absolutely, I can
Okay.
do that. So we have an application perspective called Twister Apps.
Okay.
We're going to just click on that. And what you're seeing is there is 1.49% error rate across all calls that are routed to this application, right? And if I just were to click on erroneous calls here, you can see that it's like at multiple places, and some as high as 50% and some as low as 10%. Even shipping has 0.02%. So things are propagating, and you could actually, one of the things that you could easily do in a topology view is a traffic view of red dots flowing through, and you get an immediate visualization of how the failures are propagating in your system. But what you're really interested in is immediately going into an incident view, right? So what I'll go now is to go to the events page and click on the incidents, and going to just search for our application Twister Apps. So this is our application perspective Twister Apps, and all the incidents active on this Twister app will show up now. Okay, so we have all the incidents on the Twister Apps application. We're going to just click on any of them. And what you see is, summary, but most importantly, what you're seeing here is now probable root cause feature. And this is what we built with research. And here what you are seeing is the Twister Apps. Actually, let's read this reverse. A Node.js process running on some AWS node on the Twister application is the root cause. Okay, so that is a resource. One of the entities on the large 1,000 entity graph that I was speaking about has a problem, and one of the associated events on this is that this pod just came online. Okay, so the Node.js process came online. Actually, the online, when it came up, we actually injected the problem, so it didn't come up successfully.
Yeah.
Okay, and what you're noticing is that it has got a particular pod name, right? So if I click on this, for example, what you'll notice is that it's on the catalog deployment, and catalog deployment has 4 pods. But interestingly, if we go back to our incident page, we see the exact name that appeared. So the time for you to find the root cause for a problem that could have otherwise taken, 20-30 minutes, maybe even hours, the larger the application, the larger the propagation, and the more you wait, actually the blast radius becomes greater and greater, and it becomes difficult to come to this root cause. So
Okay, so if I understand correctly, what's happened is because we've got a problem with a single instance of a service that has 4 pods, it's only one pod that's affected.
exactly.
And the problem from that propagates through the system, and we see errors occurring on different services as a result.
Exactly.
What this is essentially doing is what a skilled operator would do. They would look at the front end and say, all right, I'm seeing some errors, and have to kind of like follow where those individual error requests are coming from, and understand that they all come from the same service, but not just that service, but an individual instance of that service. And we've essentially automated here what would probably have taken at best tens of minutes of effort.
Exactly, right? And the related events, although here you have 3, and you can see the related events are pointing to payment and catalog. A catalog is actually okay because it's a triggering event, but the service impact is on payment and other things. You will get confused by your blast radius. If you were to just look at the blast radius, you will be going and chasing things that don't matter.
Yep.
And what we have done is to basically reduce that, let you focus on the exact problem. And not only that, if you have multiple incidents set or triggers set for in your application perspective, actually, if there is just one root cause across all incidents, it will be consistent. So even on this another incident which has catalog as an alert, triggering event, right, also shows the same root cause and the same pod. So despite, even if you set like 50 alerts and they are all for different parts of the application, they will all point to the same root cause. So you don't get confused. When you come to the view, this incident page view, you go exactly where you want to go, right? And yeah, that's the tech preview feature that we have built.
That's awesome. So the fact that it's kind of like accelerating what a human does means that we're reducing that mean time to repair, because we can now automatically detect that there are problems at your service level. We can automatically analyze your data and tell you what the problem is. And in the last of these episodes, I talked to Brad Blansett from the Automation Framework team about how they're providing automations to close the loop.
Actually, I can show that too.
Awesome.
So if you were to go look at this probable root cause, and we know that it is one of the pods, let's look at the recommended action. And one of the things you'll find is restart Kubernetes pod, and there you go. I'm sure you talked to Brad and he told you all about it, but this is how we are combining these two features together to reduce the time to mitigation.
And this is by having all of those links in the chain, so that we go from detect to diagnose to recommending actions to providing automations that does it, with this goal of getting your recovery time as small as possible, which of course maximizes your availability, your performance, and so on.
Yes.
Cool.
Awesome.
So we've done a whole bunch of work there that's about finding probable cause based on analyzing things like the requests flowing through the system. So what's coming next, right? That's now in tech preview. It's just coming into the product. What are you working on after that?
Well, glad that you asked. There are 2 things that we are doing. First, we are trying to enhance our user experience. So what I showed you today almost seems like magical. So we are adding a lot of explainability features. So you'll see, and this is only a few weeks. In few weeks, you'll see a lot of explainability around how we came to that root cause, how it makes sense. So we are trying to make sure that even though we are trying to automate, the humans do relate and understand what that problem was, so that they don't feel pressure to take an action that they are not supposed to, because at the end of the day, they own the responsibility of taking an action, right? So we need to make it explainable. So that's one bit that we are working on.
Yep.
The second thing that we are working on is to make it more interactive. So as I said earlier, think about your Python process. If a code doesn't work, you don't just have one recommendation, you stop there. You keep iterating until you fix the problem. So if I were to think Instana as a data warehouse with all these data coming even from third party, how do we make sure that we can leverage all the data modalities and provide you with iteratively working alongside the human, a capability or agent that basically goes and helps you find the root cause. And the more rarer root causes, the harder the problem is. And therefore, we are hoping that almost all the problems that happens today can be taken or resolved through our feature in the future. So this is in development, but we are very excited about the potential capabilities.
So lots of good stuff coming now. I know we spent the time talking about probable cause, but that's just one of the things that the research team is working on with us. So I'm sure we're going to have a lot more conversations in the future when we talk about things like NLP, predictive forecasting, etc. So thanks for spending some time with us, Saurabh.
Thank you.
Yes, I'm sure we're going to have some more conversations in the near future.
Sure, it was great to be here. Thank you.
Thank you.